Okay, class, this is our first Unit 1 test review. So what I'm going to do is I'm going to give the answer for each problem, and then so you can check that. Then you can go through, if the ones that you got wrong, you really need to watch and see how I did it, because I think that you will find this review is very similar to what you'll see on your test. So it's very important that you know exactly how to work each problem, okay? Make sure that you sign it and your name up here, because sometimes I can't read this, so make sure your name's up here, and then get your parents to sign it. Show them what's in here. You can even show them some of this video, and they'll probably think you're really smart, because this is some hard stuff, okay? But make sure that your parents know you've got a test tomorrow. Make sure they sign this. Okay, so I'm going to go through and write the answers for each one. And then if you didn't get it right, now I go through and check. You cannot just have an answer on each one. You need the work. So if you got it right and you've got all the work, great. If you got it wrong, you need to watch it and redo the work, okay? If you got it right but you kind of just guessed or you didn't do all the work, I want you and need you to watch it so you know how to do the problem, okay? This first one, this is tricky. You probably need to watch this one. It is about a negative 0.16 inches. Okay, and we'll come back and work these. The answer for number 2 is 5 1/3. 5 1/3. Number 3 is $34. Let me write it right up here. $34.32. Number 4 is $13.05. Number 5 is 1.5 hours. Number 6 is a negative $191.21. This, let's see, do I want to go ahead and do this one now? Here, I'll show you kind of mine from the one that I worked myself. Basically, you just need your irrational numbers off to the side, not a part of it. And then the big piece is rational numbers. Within that, you've got integers. Within that, you've got whole numbers. And then within that, you've got your natural numbers. Okay? So that's number 7. And then number 8 is, the fraction for it is 7 out of 24. Or I actually found the number of people, and it was 21 people. Okay, and then this is 17 peaches. And then here you should have rational. These are integers, whole numbers, and natural numbers. Okay, if you got that right, I'm not going to do this right now, so if you got this right, at the end, make sure you scroll and make to the end and make sure you've got this correct. That'll be at the very end. So fix what you need to fix, and then make sure and fast forward to the very end to get that. Okay, so now let's go through and work these. And if you notice, I did not copy these front to back so that you have all of this space plus the back of each of these pages to work, because as I've been pushing in class, the more space, the bigger you write, the more you're just detailed about it, the better you're going to do. Okay, so this first one is a doozy. So Jared is measuring the change in temperature over a 7-day period. He recorded the daily temperature for each day. Find the average change in temperatures over the week. Okay, average means to, and if you look at your, where is it? Your not your divisibility words, your rules, I bet, oh, it's not on here. Average is where you add everything up and then you divide it by how many there are. So what we have to do is we have to add up all of these numbers and then divide by however many there were, which there's 7 days. So you're going to add, then divide by 7 in this particular case. If I was saying, like for instance, what average means is if I'm finding the average number of students I have in a class. Say I have 4 classes and I've got 10 kids in one class, 15 kids in the next one, 12, and then 18. I would add up all of these numbers, and I don't want to take the time out of the video to do this, but I would add up all of those, get how many students I have total, then divide it up by the 1, 2, 3, 4 classes that I have, and that would tell me the average number of students I have per class. Okay, well that's what we're doing here. It's just with more difficult numbers. We need to add these up and then divide by the 7 days that he recorded them to find the average change in the temperature over the week. Okay, so the first thing that we need to do really is when we add up fractions or any number with the same sign, we just add and keep the sign. So I really need to add up all of my negatives, and I'm highlighting all of my negatives. Add all those up and get one big negative number. And then I'll go in and add up all of my positives and get one big positive number, and then I can do one ultimate add the negative with the positive. Okay, that'll, instead of going, okay, this plus this, then this plus this, then this plus this, I can add up all of my negatives, add up all of my positives, and then add those two numbers together. Okay, so let's get rolling on this, I guess. So we've got our, now I know these are all negative, so I'm just going to call them, I know that my answer, this is my negatives. I know that my answer is going to be negative. So I'm just going to go ahead and just take care of the numbers. 7/10 plus 3/10 plus 2/5 plus 1 3/5. Okay, well it's looking like my common denominator can be 10, meaning I can leave these two fractions and then change these two fractions to have a denominator of 10. Okay, so for 2/5 what I can do is multiply by 2 on both the top and the bottom. And that would give me 2 times 2 is 4, and 5 times 2 is 10. Okay? This one I need to do my check mark, or if you like the Texas, whichever one, I like them both. 1 times 5 is 5, plus your numerator, 3 is 8. So this is really 8/5. So I would have to multiply by 2 on top and bottom to get 10. So I'm adding the 4/10 with the 8 times 2 is 16, 5 times 2 is 10. And I'll go ahead and rewrite these down here. Okay, so then I just add all the way across. It's awesome that denominator stays the same. We're still talking out of tenths. 7 plus 3 is 10, plus 4 is 14, plus 14 plus 16 gives me 30. Okay, I'm going to go ahead and put this is an improper fraction. I'm going to go ahead and divide it. Well, I know that 10 goes into 30 exactly 3 times, or in other words, 30 divided by 10 is 3. So my negative total change is -3 degrees. So that's my total negative number. Now I need to do my positives. Okay, now I know that that's going to be a positive. And now I can take and say, okay, 2/3 plus 1/3 plus 9/10. Looking at these, I know my common denominator, 10 times 3 is 30. So I know that my common denominator can be 30. So I would multiply by 10 here to get 30. Have to do it to the top too. Same thing there. Same thing there. And then 10 times 3 will give me 30. Times 3. Okay? So I'm going to redo this. 10 times 2 is 20 over 30. Plus 10 times 1 is 10 over 10 times 3 is 30. Plus 9 times 3 is 27 over 10 times 3 is 30. When I add all these up, 20 plus 10, that's 30, plus 27 gives me 57 over that common denominator stays. Okay, when I divide this out, I can simplify it, excuse me, now or later, I'll go ahead and just say, okay, 10 can go into 57 one full time, and that leaves me with 27 over 30. Okay, and of course you can always do your 57 divided by 30. It goes in once, gives you 30 with the remainder of 27. Okay, then I can simplify both of these by 3. 27 divided by 3 is 9. Sorry, I'm having to squish that. And then 30 divided by 3 is 10. So really, I have 1 and 9/10. Okay, so my positive number is 1 and 9/10. Kind of having to write over. Okay, 1 and 9/10. So now I can add up -3 plus, can you see that okay? It's not green. I'll use my darker green. -3 plus a positive 1 and 9/10. Well, according to my foldable, this is where it can be tricky. My foldable talking about, same signs and different signs. When they have different signs, which these do, one's negative, one's positive. Same sign, I find the difference of the absolute values, meaning just ignore the positives and negatives, and I'm just going to find the difference between 3 and 1 and 9/10, and then use the sign of the larger absolute value, basically just the larger number. Okay, so 3 is the larger number, so I know my answer to this is going to be negative, because it's negative. Then all I have to do is say 3 minus 1 and 9/10. Okay, here's how I did it. You could make 3 a fraction by putting it over 3 over 1, or I knew that 9/10 as a decimal was 0.9. If you didn't know that, that's okay. You can do top end 9 divided by 10, and it comes out to 0.9. So what I did was I'm saying -3 plus 1.9, and when I'm finding the difference of the just 3 and 1.9, I said 3.0 minus 1.9. When we have our decimals, we have to line them up. Okay? Well, I borrowed from there, did that. 1, 2 minus 1 is 1. So my answer is a -1.1. That's the total number I got when I added all of these up. Okay? Now what I have to do is go in and divide that up. So I've added, it's a lot of adding. Then I have to divide it by 7. So -1.1 divided by 7 is what I'm doing. Okay? That's a negative there. So first of all, when I'm at my multiplication rules and division, which you have right here. So when let's say I'm dividing, when they have the same sign, your answer is positive. Different signs, your answer is negative. Well, one's negative, one's positive. They have different signs, so my answer to this is going to be negative, and I marked that right away. And then that first number, when you build your little house, goes in 1.1, and then your 7 stays out here. Okay? For the sake of time, I'll let you do this one on your own. But this ends up going out to, well, actually, let me show you where I did it right here on mine. So, 1.1, you put your decimal straight up, and there's my division, okay? And it ended up, it was going to go on, so when I got to 1.157, I went ahead and rounded that to 0.16. Instead, it's about a negative, because I knew that the answer to this division problem was going to be a negative. I'd already put that there. And so I said it was about, that's when you do the little squigglies, a -1, or 0.16, I'm sorry, 0.16, okay, inches. Alright, so that was a doozy. Now, it's mainly you just have to know that it's going to take a long time. That's a lot of work. You got to add them up all together, then you divide them by however many there are. That's what average means. Okay? Alright, the following expression, this is a PEMDAS thing. You have to follow your order of operations. Okay? So you first, you do what's in parentheses. Well, that's just a number, 2.5. So we've got that. Exponents, we don't have any. Multiply and divide go together. they're in love, they go together, and then add and subtract, they go together, okay? Alright, so I'm going to, and you go left to right on these. So I'm going to multiply -5 and 2.5 together first. So I've got, when you multiply with decimals, you just put the bigger, and you've got foldables over this. This one looks like, right here. Decimals multiply. The number with the most digits goes on top, okay? And you have your notes for every single one of these, and like I've been pushing you to do in class, it's like, okay, I need to know how to multiply decimals, go to that foldable. Then when it comes to fractions, go to that foldable. When it comes to so-and-so, go there. And that's what you just have to do. I want your pages to have finger marks and everything all over them because you've been going back and forth. Okay, so anyways, 2.5 times a -5. Now, I know that the product of that, since one's negative, one's positive, we just looked at that foldable, the answer is going to be negative. Once I've got that established, I don't really have to deal with the negatives. I can just write them as regular numbers. 5 times 5 gives me 25. 2 and 5 gives me 10 plus 2 is 12. Okay? There's one number after the decimal there. There's none after the decimal there. The decimal would be right there if there was one. So total in my answer, I need one number after the decimal. So I'm going to go 1 and place my decimal. Okay? So this, now I rewrite. I always rewrite. So this was a negative 12.5. Now I'm going to add 2 and 1/2 minus 6, and then ultimately I'll divide by 3. Okay, so you can do this a couple of ways. You could know that 1/2 or 0.5 is 1/2 and change that to a fraction, or I know that 1/2 is 0.5 and it's easier to add up decimals. So I'm going to say, okay, negative 12.5 plus 2.5. Okay, well, on my integer rule, so you're back to this foldable, different signs. We keep the sign of the larger number, which is 12.5, so the answer is going to be negative. And then we find the difference, or subtract these two. So I say 12.5 minus 2.5. That decimal point comes straight down. That gives me 0. That gives me 10. So it's a negative 10. So this right there just became negative 10. So I rewrite. I say negative 10 minus 6 over 3 divided by 3. Oh, it's a negative 3. My bad. Okay. Now, on this same foldable right here, when we subtract, it tells us to change the subtraction to addition. Okay. Check. Then change the sign of the second number. Okay. Check. It was positive. I just made it negative. Now I'm adding up a negative 10 and a negative 6. So they have the same sign. I go here. You basically just find the sum of the numbers and you keep this sign. Absolute value means just ignore the negative. So if I just say, okay, 10 plus 6, that's 16, and then you keep the sign, they're both negative, so it's negative 16. Or you can think of it as on a number line. If you were at negative 10 and you go back 6 more, you're going to end up at negative 16. Divided by negative 3. Okay? So now, since they're both negative and I'm dividing them, they become positives. Okay? And that's, oh, I've got this all messed up. Okay, right here, you're dividing, this one. When you're dividing with the same sign, the answer is positive. So I knew that these were going to be, this was going to equal something positive. So a fraction, 16 over 3, basically just means 16 divided by 3. And I can say, okay, 3 can fit into 16 5 times. That would give me 15, so I'd take out 15 of those, and I'd be left with 1 over 3. Okay, and again, if you don't like to do it that way, you can do the 16 divided by 3. Goes in 5 times. Gives you 15, the remainder of 1. So there's your whole number. There's your remainder over 3. Okay, 5 and 1/3. Okay, we better pick up the pace. Okay, this one is another doozy. Again, I don't make your tests, so I'm with you when we think they're hard. I agree. Okay, so Sarah's going to buy 1.5 pounds. It's so important that you look at the words. 1.5 pounds of chocolate covered almonds. Okay? Well, if we look up here, the chocolate covered almonds, I'm going to kind of shade that purple. They're 3 pounds for $7.50. Well, I want 1.5 or 1.5 pounds. Okay? Well, now this is just, I know that half of 3 pounds is 1.5. So I need half of $7.50. If I'm buying half of the pounds, I'm going to pay half of the price. If you don't know that, then what you're going to do is divide up. Well, I'll show you what on another one. What you would do if you didn't know that 1/2 was 3. Okay, so what I'm going to do is I'm going to say $7.50 divided by 3. Okay, that decimal point comes straight up, and then you divide like normal. Okay, and I'm going to let you do that one. Alright, the 4 12 packs of candy bars. Well, 12 packs, 3 of them are $6.99. Well, she wants to buy 4 of them. So I can't just use the $6.99. Here's what I have to do, and here's what you would do up here if you didn't know that 1/2 was half of 3. I'm going to say, okay, $6.99 divided up by the 3 12 packs. Put my decimal straight up. 3 goes into 6 twice. It goes into 9. 3 goes into 9 3 times, and 9 3 times. So the price, this is telling me the price per one. If 3 of them are $6.99, I just discovered that one of them was $2.33. Well, if she wants 4 of them, what I'm going to do now is say, okay, it's one of them's $2.33 times I need 4 of them. 12 plus 1 is 13. 8 plus 1 is 9. I've got 2 decimals after, or 2 numbers after the decimal there, none here, so in my answer I need 2 numbers after the decimal. I'm going to come in 1, 2, and put my decimal point. So this one was $9.32 is how much she spent on her candy bars. Okay, then she needs 5 packages of mixed candy. Okay, so this is the mixed candy, so be sure not to flip-flop that. So they're $3.25 each. So now I come and say $3.25 times the 5. Okay? I'm going to let you do that one on your own. You're going to multiply it just like that to figure out how much money she spent there. When you put how much money up there for the chocolate covered almonds. Okay, and then lastly, she wants 2 bags of the giant licorice. Well, the giant licorice is $2.50 each. So I would say, okay, $2.50 times, she wants 2 of them. So I'd multiply that and then put that amount right there. Okay? So that's, and I want you to do some of these on your own for that one. Then, so it's important, I'm sorry, I'm wanting to be very careful on this one. It's important for you, for these ones, to know that you're going to, the price that you see right there is not the price that you use. You're going to have to take this and help it, or use it to help you figure out how much she's going to pay for what she wants. Now on these, down here, it tells you for 1, that's how much it is. Well, she wants 5, so you take the price by 5. She wants 2, take the price by 2. Here's the thing, these math tests are like 90% reading and 10% math most of the time. You've got to be able to read and you've got to be careful. That's why I color-coded all of that, and I highly recommend it. If you need to borrow colored pens tomorrow, if you need to borrow highlighters tomorrow, I will gladly give you them, okay? Then you'll have your 4 prices, and just make sure you line up your decimals when you add them all up. Line up your decimals. Okay? Alright. Now, so Joseph and his friend, they both got their part-time job at the golf course, $9 per hour. Okay? He worked 14.5 hours his first week. So right now, I'm pausing because I'm saying, okay, well, how much money did he make then? Per tells you to multiply. That is on those keywords right there. If you don't know that, that's fine. We're going to get these memorized. Multiplication, there should be per on here. Each or per right there. Per means to multiply. So I'm going to take the 14.5 hours he worked and multiply it by the $9 per hour. Okay? I know that 1/2 is 0.5, so what I'm going to do is say 14.5 times 9. Okay? 5 times 9 is 45. 4 and 9 is 36. Plus 4 is 40. 1 and 9 is 9 times, or plus 4 is 13. Okay? There's one number after my decimal place there, none there. So in my answer, I need one number after the decimal. So 1 and place it. So this is dollars. This is how much he made. $130.50 is what he made in his first week. Okay? Then he agreed to pay his friend 1/10 of his salary for reimbursement of gas. How much did he pay? Okay, let me check. I'm assuming it doesn't say on your words. Well, we're basically finding 1/10 of or times his $130.50. Okay? Well, this is a fraction. I can make this a fraction by putting it over 1 and multiplying across. 130.5050 divided by 10, which is 10% is your dividing by 10. And so you would say $130.50 divided by 10. That decimal point goes straight up, and you know how to divide from there. So for this, to keep your video not extensively long, I'll let you do that one on your own. Okay? If you know, some of you know this, and we'll talk about this later in the year, when you're finding 10% of anything, you just move that decimal spot in once. So when our answer came out to 1305, that's why. When you're finding 10% of something, if you move that decimal point in once, that's 10%. So 10% of it was the 1305. But if you don't know that yet, and we'll learn that trick later in the year, dividing, there's no shame in that, or that doesn't mean you're not good at it. It just, you didn't know the shortcut, which is fine. We'll teach it to you. Okay? So that's that problem. Alright. Then, goodness gracious. Okay. We got more fractions. Woohoo! Alright, so Edward, he's required to practice his guitar a total of 10 3/4 hours in 1 week. So he's practiced this many hours already. If he splits his remaining required practice time equally for these 2 days, how long are they each going to be? So basically what I need to do first is find out how many hours he's practiced. Okay? Then subtract that from the 10 hours and 10 3/4 of an hour he has to. That's going to give us how, it's going to equal how many hours he has left. Then I'm going to take that number, so however many hours he has left, I have to divide it up by 2 because he's got Saturday and Sunday to get it done. So he's got 2 days to get it done. And that's going to be my answer. Okay? Alright, so I kind of took up that space, so now I'm going to show my work over here. So, he's got his, here's what I'm going to do. I'm going to take the whole numbers, 1 plus 2 plus 1 plus 1 plus 1. That is 6. So I know he's gotten 6 full hours. 6 hours. Plus, now I have to add up the fractions. Plus the 1/3, plus the 1/2, plus the 1/6, plus the 3/4. 3/4. Okay? So, looking at these, I see that all of them can be turned into 12. 3 can be multiplied by 4, by 6, by 2, by 3. So I can turn all of these into 12, so there's my common denominator. I'm going to go ahead and write it across the board. And since when you add, you keep that same common denominator, I'm going to go ahead and just put it right there. So I'm going to say 3 times 4 times 4. 3 times 4 is 12, 1 times 4 is 4. 2 times 6 gives me 12, and then the 1 times 6 gives me 6. 6 times 2 would give me 12 there, so I multiply by 2 up there, which would give me 2. And then here I multiply by 3 to get 12 times 3. 4 times 3 is 12, 3 times 3 is 9. Okay? Then I just add up my numerators. 4 plus 6 is 10, plus 2 is 12, plus 9 is 21. Okay? So that's how many hours they practiced. Now I can go ahead and say, okay, that's 1 and 9/12. 12 can fit into 21 one full time. So if I take out 12 of those, that leaves me with 9. So that's how I got my 1 and 9/12. I know that this can be simplified. These can both be divided by 3, leaving me with 3, and 9 divided by 3 is 3, 12 divided by 3 is 4. So 1 and 3/4 is the adding to the fraction. However, don't forget, I had my 6 full hours. So the 6 plus 1 gives me 7, plus the 3/4. So, I hope I didn't confuse you just there. I feel like let me back up. If this confused you, what you can do is you can say, well, you could have simplified the 21 divided by 12 right away. They're both divisible by 3. 21 divided by 3 is 7, and 12 divided by 3 is 4. Okay? Then you can say, okay, 4 goes into 7 one full time. If I took away 4 of those, I would have 7 minus 4 is 3 out of 4. So that's how I got the 1 and 3/4. And then, as always, if you don't like doing it that way, then you just divide, okay, which is completely fine. You'll get the same thing. So then I took this all added up to 1 and 3/4, but I had to add it in with the 6 full hours. Remember, I went ahead and just took my whole numbers and then added up those fractions. So total, all of that has added up to 7 and 3/4. Now, I need to subtract that from the 10 and 3/4. Well, at least those are pretty numbers. 10 and 3/4 minus 7 and 3/4. Well, 3/4 minus 3/4, if you have 3/4 and then you take away 3/4, you have nothing. It's 0. So we've got rid of those. Then 10 minus 7 is 3. So he has 3 hours left to practice. Okay? We divide that up by 2. 3 divided by 2. And I happen to know that it's 1.5. If you don't have that memorized off the top of your head, you just divide. Goes in once, remainder 1, add your thing, 5. Okay? I did that kind of sloppy, I'm sorry. I'm trying to make your video fast for you. Okay, then we've got Jessie discovered an error in her checkbook register and recalculated her balance, determining that she was overdrawn. Her balance is the negative $964.31. That is not good. Okay, so she saved 3 of her paychecks. Each was $257.07. If Jessie deposited all of those into her checking account, what would her balance be now? So basically what we need to do is figure out, okay, she's that much in the hole, $964.31. If she's got 3 of these 257s, we have to figure out how much money she does have to be able to put in there. So I'm going to say 257.70 times 3. Now this 0 is kind of irrelevant, so I can just go and multiply like 3 like that, by 3 like that. Okay? 7 times 1 is 21. I'm so sorry. 7 times 3 is 21. 7 times 3 is 21 plus 2 gives me 23. 5 times 3 is 15, plus my 2 is 17. 2 times 3 is 6, plus my 1 is 7. Okay? Here, there's one number after the decimal. There's nothing. So in my answer, I need one number after the decimal. 1, and put it. Now, since I took off that 0, and this is money, I just need to add it back on. And I could add zeros forever, but really this is just $773.10. If you didn't understand why I took off the 0, that's totally fine. Leave it on and multiply by 3. You're just going to have a 0, and you'll just have to do one extra step. Okay. Alright, so she's got $964.31 negative. So she's got to add in her $773.10. Okay? Well, I'm adding up, and this would be your, let's see where that foldable is. This foldable again. And they've got different signs, so read those. You keep the sign of the bigger number. Well, this one's bigger, so it's negative, so my answer is going to be a negative. I'll put that right away. And then you find the difference of just the numbers. Ignore the positives and negatives. So I'm just going to subtract 964.31 minus 773.10. Okay, your decimals have to be lined up when you subtract. And you just subtract. Don't forget that the answer is negative, and there's your answer. Okay. The visual representation. Basically, as long as you know that we've got, and you can do a circle, whatever, the big pieces are rational numbers. Everything's rational, and then we've got over here, we've got our irrational. Okay. They're not any part of this. Then within rational numbers, just kind of like we have our Lubbock Cooper ISD, then within there we've got some smaller subgroups like Laura Bush. So we've got our rational numbers, and then within there we've got, I should have drawn that bigger, integers. Okay, so we've got like our Lubbock Cooper, and then we've got our Laura Bush. Everybody in here, all of our Laura Bush students are still Cooper Pirates, but they're in this smaller subset. And then within that we've got our, I'm going to have to go right over here, our whole numbers, okay, and that might be the 7th graders. So you could be listed in here, but you would still be able to be listed out here as a Laura Bush student, and still be able to be listed out here as a Cooper Pirate. And then we've got one last one of, mine, yours should look a lot better than this. Mine is not looking too pretty. We've got our natural numbers, okay? And so that could be just Miss Woolsey's 7th grade student. You're still a 7th grader, you still go to Laura Bush, you're still a Cooper Pirate, but you get to be in these subsets, okay? Alright, so that's your visual representation. Alright, then we've got, we're almost there. Okay, we've got the volleyball game. 72 people. They bought items from the snack bar. 3/8 of them bought popcorn, and then plus 1/3 of them bought soda and popcorn, and then however many left bought just soda. So what we have to do is we have to add up these two to figure out what fraction bought between these two, by either just popcorn or popcorn and soda. So that's going to tell us that. Then to find the remainder, we're going to have to take the whole thing and subtract this. Oops, I'm getting lazy, I apologize. Okay, so I'm going to take the whole thing and subtract from however many those are, and that's going to give me however many is left over, which is that. Okay, so let's just do it. That wasn't a great little picture, but let's just do it. So I need a common denominator. I know that both 8/3 and 8 and 3 can be turned into 24. 8 times 3 is 24, so that's my first denominator. So I'm going to go ahead and say 24 plus 24, and that's going to equal something over 24. Okay? 8 times 3 is what will change into 24. 3 times 8 is 24. 3 times 3 is 9. Okay? 3 times 8 will give me 24, so I've got to do it up top. 3 and 8 give me 24, 1 and 8 gives me 8. So when I add up 9 and 8, that gives me 17. So 17 out of 24 people are covered by the popcorn or the soda and popcorn. Well, what I need to figure out is how many people are left. So really, I'm going to say, okay, 24 out of 24 people, which is one whole. So if 24 out of 24 people went to the snack bar, which the 72, that's a distractor. So because that's not really relevant, it's 24 out of 24 would be one whole. Then I'm going to subtract the 17 out of 24 that are accounted for right here. Okay? When I subtract, that denominator stays the same, and I just subtract my numerators. 24 minus 17 gives me 7. I think, right? I've done so many problems today. Yeah, 7, okay? So that's how we got the 7 out of 24. So you got to add these two up and then subtract it from a whole, which 24 divided by 24 would be 1. That's why I put 1 whole, okay? Just for a side note, if this fraction would have been, if the common denominator would have been 48, so say I had 34 out of 48 people, all I would do is say 1 whole would be 48 out of 48. And I would subtract away the 34. You just keep that. We would just want it to have the same common denominator. This is still representing 1, because 48 divided by 48 equals 1. Okay? Alright, this one, the table below shows the prices of fruit at the farmer's market. What is the greatest amount of peaches that can be bought for $2.15? So I'm saying, okay, peaches cost 12 cents per unit, and I've got $2.15. So what I'm saying is $2.15 divided up by 12 cents. Okay, so I've got my 2.15 divided by 0.12. You cannot have a decimal out here. No, no, no. So I have to move it. So to make it a whole number, I would go 1 spot, 2 spots to make it 12. So if I do that outside, I have to, outside I have to do it inside. 1 spot, 2 spots. So put your decimal. So I rewrite, and I highly recommend it, just because it kind of clears it up. So I've got 215, and then I've got 12. That's where my decimal would be, and I would bring it straight up. 12 can go into 21 once, and that gives me a remainder of 9. And I drop down my 5. And 12 can go into 95 7 times, which I'm blanking right now. 12 times 7, 14, 84. Well, and then I would get a decimal. But here's the thing, and we can finish this. I'm going to have to go like this. 11, drop down a 0. 12 can go into 100, I think that's an 8. Okay, well, you can't buy 0.8 of a peach. So, and if you don't have enough money to go ahead and buy the 18th peach, you're just going to have to be okay with 17 peaches. So that's how we got our 17 peaches. You can't buy 0.8 of a peach. They'd look at you funny if you went to the store and cut off just the end of a peach and said, I would like this 80% of this peach. Okay? Alright, so there's that one. And then I do want to re-say here, just to make it clear, yes, if we were rounding, 0.8 would mean we'd go up to 18. However, you don't have enough money. It cuts you off. So you cannot afford that 18th peach, so that's why we rounded down to 17 peaches. Okay? I just want to make that clear on that one. Okay, last one. I kind of gave this answers away, and we did this just a second ago. But I want to talk about, it's just talking these, each of these, kind of what they are. And we've talked about all of these. But if we start with our natural numbers are in the very middle, so let's kind of define those first. If you remember, and you've got this, actually, and I'm going to kind of let you do this one because you've got this in your notebook, and we've got the definitions right here for each of those. So I'm kind of just going to talk you through each one, and then you can write something down. Remember, these natural numbers does not include 0. But other than that, they're just your counting numbers. 1, 2, 3, 4, 5, forever and ever. Okay? Then, right outside of natural numbers, we've got whole numbers. It's the same thing. Those are your counting numbers. However, they do include 0. So there's 0 in whole numbers. Then your integers are next outside of that. That is your number line numbers. So anything you'd see on a number line, positive and negative, but there's no decimals, no fractions. Then lastly, we've got our rational numbers, and that's everything. That includes all of these. All of these are inside rational numbers, but then rational numbers are, you can have a decimal, you can have a fraction, you can have a negative decimal, you can do it all right there. Okay, so those are each one. Make sure and jot those down, and you can just copy out of your notes. That's fine by me. Okay, so make sure that you understand all of these questions. And if you need to pause and rewind, that's why we do the video, so you can do that. Okay, if not, let me know any questions you have, and good luck on your test.